Marshall, I heard it gets hot in Texas.
We've got two seasons in Texas. We have first summer and we have second summer. So,
All right. What are the most promising cooling technologies currently being deployed to handle Texas's extreme heat in mining operations?
a lot of people still run air mines here. The challenge is not only heat, but also, the upkeep, the maintenance. The guys that ride do a great job, but, it's a tall order. Their new site there's a lot of immersion there, and it's not necessarily just for cooling efficiency, but it also keeps the machines much cooler and cleaner. So, longevity of your machines is a big part, because in some places in Texas, it's so humid that even if it gets dusty, you can get shorts. So like mining in Houston, pain in the neck just because it is so humid. So there's the heat, there's the humidity, there's dust. A lot of these places are on job sites, construction sites. All that stuff is, reason to seek alternative measures. And then when people ask me, well, do you want two-phase cooling? Do you want a regular single-phase cooling? Do you want hydro? What's the take? And I ask people, where do you want your pain and when do you want it? If you want to do hydro, your pain's going to be up front because it's expensive. And the setup is not trivial. It's a little bit different than normal setups. It's going to cost you a lot, but, you're going to eat it all up front. Immersion, single-phase immersion is a little bit of a longer process. It's less expensive. There's other reasons why you might want to do it. You can use off-the-shelf air miners that you retrofit. It's only been very recent that OEMs have been making immersion-specific machines. And then, air, it's easy to start, but to keep it going, you're going to get your pain on the back end forever. So you just got to pick your poison and where you want to deal with it.
Have you taken any operations that were like air and then decided to upgrade them to like hydro or immersion or?
Yeah, sure. So that's a bit of an easier task. Doing it the other way, much bigger pain in the neck. You got to take apart the machines and do all these kinds of stuff. I mean, if you want to hear, terror and war stories, Mr. Schatz and I could sit around a fireplace for many hours and cry many tears about how that works. So it's better you make your choice the first time, and then you never have to make it again.
And then just stick with it. Yeah. How do air-cooled and liquid-cooled, or hydro-cooled for that matter, systems, how do they compare in performance, cost, long-term reliability, specific to the Texas climate?
Yeah, sure. So the hydro is just kind of like a newer thing, so it's a bit harder to say long-term how that shakes out. It's gotten better. The difficulties there are, if you have to take those machines out, those can be 80 pounds a piece, so it's really hard on the ops guys and gals to do that stuff. It's backbreaking to install those, especially if they go out or they have power supply problems. Water and electronics doesn't really mix that well, so there's other additional safety concerns there. However, you get a benefit of if you want to use the heat for other things. So like where this beer is made, we have a hydro setup, and off the manifold, we preheat the water using the hydro setup. And so, it makes heat reuse much easier. It's just they're heavier, they're more expensive, but they use more power. So they're three-phase, so how your power is set up is a consideration. If you only have single-phase power, probably not the right fit. The immersion has a benefit of being able to use immersion-specific things or being able to convert air miners to immersion miners as well. So those are kind of the main considerations there.
Do you find yourself running like a mix of different cooling techniques in one operation, or is it just like across the board? This whole setup here is going to be all air, or this one's going to be all hydro?
Yeah, usually, unless it's like a long-lived site, like the Riot site's a great example. That's been a very long-standing, massive operation, and they've iterated with the times, and you can kind of see that iteration as they go on. Their building design changed, and their infrastructure setup changed a little bit as they got smarter. But if you're just like new getting into it, most setups are going to be just one and done, unless you're a big guy who's got a huge long power contract. If you're not trying to go super mega industrial scale and you're going to have to change as the years go, you're probably just going to have one setup. You're going to make a choice and you're going to stick with it.
And then what role does facility design play in maximizing cooling efficiency and overall energy sustainability?
Yeah, the design is important. It's the most important. I'll give you a good example. So when you do an immersion, right, and Cameron will tell you this, and all the guys at Shell will tell you this, the fluid you choose, that's a really big consideration. There's a lot of vendors, right? You got, Exxon, you got Engineered Fluids, and they all sell what they claim is different, right? But as time goes on, you can tell those products are mostly the same or widely different. You can see fluid changing colors, and then it becomes more acidic, and maybe it eats all your machines, right? So doing work on the chemistry side for immersion is like huge. It's less about the price today as it is the price over 5 years, because the fluid is not free. As much as Cameron would like to sell it for free, well, maybe he wouldn't like to sell it for free, but that fluid's expensive.
Yeah, and does it come with guarantees? Like we guarantee you can run this fluid for 2,000 hours before it needs to be changed? Or?
I mean, every vendor's different, right? So what each vendor will say, most of them will say that their stuff has been signed off by the manufacturer, that and maybe it doesn't void your warranty, stuff like that. And they've done work with the manufacturers, but the chemistry is different and unique between all of them. And so, when we first got into immersion in like 2018, we just used mineral oil, and over time that stuff breaks down, and I had a host of S9s just get fried because it became conductive. I didn't know that could happen. So microfluidics engineering is like a whole field, and you really got to do your diligence before you just buy the cheapest or what they claim is the best. There's a whole bunch of considerations around what pump do I use? Does it change viscosity when it changes temperatures? Like there's a bunch of stuff, and every vendor's got different aspects. So another example of if you got a certain type of fluid, maybe your fire suppression system has to change to meet code, right? Is the flash point of this fluid so high that maybe you don't need fire suppression in your building? There's a lot of give and takes there.
Wow. Yeah. So that goes into the design of the facility too. Are the manufacturers like suggesting or dictating like you've got to use this pump if you're running this fluid, or like, we can't guarantee results if you're running this other type of pump?
Not generally. They're not going to really make a recommendation on like infrastructure. They'll tell you what they've used before and maybe try to like guide you. They'll be as helpful as possible. But most pumps for more or less are just it's a reliability thing. You buy a cheap pump, it's probably going to crap out earlier than a nice pump. They'll give you more guidance around like flow rates, and they can at least Shell anyway, they've been very helpful. They'll do like a fluid simulation of your design for you and say like, oh, maybe you can optimize here. Maybe this drop of this pipe could be different. Like it's at scale when you're buying a lot, that's more collaborative than just buying stuff off the shelf. So I'll say they'll help you as much as they can, but they're not going to vouch for other companies' equipment.
Can they like help you in supporting ways, like doing like oil analysis after the fluid's been in use, and kind of give you an idea like the type of metals that are starting to show up and break down?
Yeah, so that's a big thing that like a good fluid vendor should offer you, where you're, maybe you have a chemist that can do small scale testing like voltage breakdown, to see at what point does a fluid conduct the electricity, or acidity levels. But if you have a good vendor, they should say, hey, like once a quarter or once a month, send us a couple gallons as a sample.
Yeah.
And they'll do like full crazy testing. Like Shell's got a FTIR machine, which is like a multi-million-dollar machine that can tell you this is how much dissolved silicone from a thermal paste is in there. This is XYZ. Here's your fluid is aged XYZ. They'll give you the whole breakdown. So any good vendor should have a testing facility to do that for you.
Yeah. And then how many miners are balancing the trade-offs how are miners balancing the trade-offs between upfront investment and operational savings when selecting cooling infrastructure?
Yeah, and I think that's a question that's going to change based on two things. The public guys are going to play a different game than the non-public guys. Public guys have a bunch of different considerations. Right now it's, I would say the majority of public miners is let's grow at all costs. Some of them have chosen different treasury management strategies and that kind of stuff, and all those kind of, I would say, take a front row to these kinds of design choices. I think the industry for hydro, and Tyler and I were just talking about this, is evolving rapidly. MicroBT is putting out stuff that's like single phase power for exclusively for heat reuse. The Ardyne guys just got into hydro recently as well. So there's a bifurcation between strategies because they're playing different games, right? So the arbitration between what they're going to do really comes down to scale and how you can do certain things. Because what I do with my little 10 megawatt shack might be okay, in downtown Houston. But if I do those same kind of things inside of the city limits somewhere else, fire marshal's going to get involved. Like, you can't do things the same way. And there's a bunch of trade-offs. Fire suppression being another example. A guy will come in, well, because this fluid XYZ, he's going to look at like a safety data sheet, and he wants to see when does this fluid become flammable and all these other considerations that mid-tier and small-tier guys don't even have to think about.
I imagine there's like the peripherals can just kind of spiral out of control. Where
all it takes is the fire marshal to just say, nah, we're going to revoke your certificate of occupancy. Guess what? You can't work there. Then it becomes illegal because one guy had a bad day. Yeah. So, there's a lot of considerations, and you got to be able to point to, the fire code, like, no, that's not the case. And, that's where having a good vendor for, even hydro, because they'll put additives in the water to reduce scaling and fluid. And also, like, the infrastructure providers, you've got to work with them so the laws. And so, one guy having a bad day can't shut down a $1 billion operation.
Right. Do you find that, like, ASIC manufacturers are making suggestions about, like, what, like, hydro to run through their miners, or, like, what immersion their miners can go into? Or, like, are miner manufacturers and immersion fluid manufacturers working together, or do you have to kind of play that role of liaison?
Yeah, that's a good question. I can say that, there have been OEMs that have worked directly with the fluid providers. If you wanted details and specifics on that, you can definitely ask Cameron. I don't know what's public and what's not, but I can say that when they come up with a new fluid, most vendors will reach out to the OEMs and say, hey, can you like put this on an approved list, saying that, gotcha, hey, we've tested this, we've tried this. There is some behind the scenes like co-development, I would say, for use case specific applications. I know Engineer Fluids does a little bit too. So it's not just here's a fluid, because what works for Bitcoin miners is not necessarily what works for guys running GPUs. They want different volumes and different viscosities. So it's not like a one-size-fits-all thing. So there's a lot of collaboration, I'd say, for sure.
All right. What innovations on the horizon could redefine how we approach thermal management in large-scale mining under high heat conditions?
Yeah, that's what's really interesting is everybody's like, oh, AI, HPC, blah, blah, blah. If you go to any HPC conference, these people think that cooling 1,000 watts is like cutting edge, insane, like nobody can do it. So I went to Open Compute like a year ago, actually with Cameron, and I walked in, and the guys at I think it was Intel, they had this little mini immersion set up, and they had the processor clocked to like 900 watts, and everybody there was like, oh my God, this is so revolutionary. And I'm just like, this is like 5 years ago.
Wow.
So the fact that Bitcoin has like just blown HPC out of the water from like what we can cool. When we were talking to vendors, they're like, oh, what flow rates are you pushing? And like, it's several orders of magnitude beyond what any HPC data center is doing. And it's interesting when you like sit down with these people and say like, oh, like we're moving like, 1,700 liters a minute. They're like their face melts off, and you're like, we'd like to be faster maybe, or whatever. They just never thought that like cooling, in one small footprint, 5,000 watts is like even thinkable. So the fact that the AI guys are starting to learn from the Bitcoin guys, it makes us feel like we're not little boys anymore. Like we're big guys are starting to pay attention a little bit. So that's been really cool to see. As far as like what's changing, I think the biggest change is the OEMs. Like MicroBT was the first to come out with like an immersion specific SKU. Riot famously purchased a lot of those. Those are interesting to see because before you got to take the fans off and have special firmware and like really do all this bespoke stuff, which just takes times away. Bitmain started shipping SKUs without fans. Ardyne's got SKUs without fans. So seeing the OEMs kind of tailor to us now instead of us trying to like, square peg, round hole situation
right,
has been good to see. you go into any, if you're a big, like you buy $100 million of Microsoft contracts, they're going to have a guy there to help you make your stuff work for you. And that's just now becoming the case for Bitcoin. And it's good to see. Because before, everybody's just like, oh, you can't figure it out. You can't hack our firmware or whatever. That's your problem. No, you can't have SSH access to the boards. And it was like pulling teeth up until 3 years ago maybe. But now they're starting to come along and see like, look, we now have the money to hire serious professionals, serious electrical engineers. If you're not going to build it, we'll build it ourselves. So you can either come along or, not. And now to see the OEMs kind of play ball a little bit has been really encouraging. So
yeah, I imagine like they're looking at this like if they don't do it, their competitor's going to do it. Right?
Not even that. If they don't do it, we'll do it. So like early on, I don't know, maybe 2020, MicroBT wouldn't give you SSH access unless you really begged and pleaded. But the tool that they had a SQL injection vulnerability. So we would just give ourselves root access through the WhatsMiner tool. And, you can just SQL inject through the WhatsMiner tool by updating your pool. Okay, cool. And then for like 2 years, it was cat and mouse. They would patch that. We'd find another one where if you shove an SD card during post, it'll dump the firmware. And now you got the firmware and you can do all these things. Like just this whole adversarial kind of, when I'm spending hundreds of millions of dollars with you, no other vendor would have done that in the professional world, right? Right. And so now it's starting to kind of come back to where it should be, which has been very useful for just running a good operation.
Have you been confronted with like environmental concerns, like cooling Bitcoin miners with hydro uses a lot of water?
Yeah.
How do you counter those?
There's most of the marketing now. There's a very infamous Bitcoin site that I will leave names out in West Texas where these guys used Bitmain cooling. They had like a cooling tower and the Bitmain hydros, and they had to drill wells. And they started a reverse osmosis water treatment plant in order to get enough water to run in their cooling tower. And then as the water table depleted, the water got more and more briny and more salty, and then their RO system got clogged up. And then their site failed, and then it was like a whole massive thing. And so now anybody doing a tour, their big selling point from these, like let's say HeatCore, for example, they'll say, you don't have to add any water. Once you fill the system up, that's it. It's a closed system.
Right.
That's everybody's marketing point now is we don't use water. Beyond that, it just gets so freaking hot that OEMs are starting to use better components. Like MicroBTs and Auradines hydro units can withstand like 65 Celsius degrees or 75 Celsius degree water coming into the machine so that you can use no water. And so outside of that, it also depends on where you're located. If it was a previously EPA investigated site, you get one drop of immersion fluid outside the containing wall of your building. It's a whole like EPA shutdown. They got to come and do soil studies and sampling and all this other crap because somebody before you had messed up the site, right, from like a previous business or whatever. So, anything you can do to keep things contained is super important because it just takes you spilling a couple of liters of immersion fluid outside a previously condemned site, and the EPA shuts you down for a week while they do this sample study for like a gallon of milk spilling outside, basically, like rainwater runoff, all this kind of crap. Right. When you hit scale, it's like a huge operational overhead. So anybody here that that runs a big op, they've all got to deal with this crap. And it's a very serious time and money sink to do that. And so working with the people to make sure that you can limit all those risks long tail is super beneficial.
Yeah. We've got 5 minutes left. Are we going to take questions on this panel? All right. I'm wondering if you've got any like funny anecdotes from your experience as it relates to like keeping miners cool. Like,
yeah, we used to do this thing where if you start working, I still do this in my current facility, my little test lab. If you come in there and you want a tour, you have to taste the fluid.
No, you don't. Come on.
Hand to God. I make people put a little finger in there because the good fluid is all biodegradable. They use it in like makeup and stuff.
It's like food grade?
Yeah,
or?
Yeah. And so that's like my first like rite of passage. If you want a tour at my dojo, you got to taste it. And the feedback, at least for the shell, I don't know if you guys gotten this feedback, but your fluid has a slight buttery taste. So that's the most common feedback we get. I don't know if that's useful, but maybe a selling point. We also we like to sous vide steaks in there as well. So for lunch, we get out the flamethrower, finish it off. It's the perfect temperature for like a nice. It's a little bit too well done for my taste, but a nice like medium. We do a lot of sous vide in the tanks. So yeah, those are just a few of what I can mention publicly. So
that's awesome. Let's give Marshall a round of applause here.